1.4 is on functions. So the first thing in 1.4 is the definition of a function. For a function, all elements of the domain must be used. If you recall, domain is the x, so all of the x values must be used. Each element of the domain or the x matches with exactly one element of the range, which is the y values, okay? So for example, on this first table here, this is a function. Why is it a function? Because the x values are 2, 7, and 8, and they are all used. And each of the x values matches with a unique element of the range. So the 2 only matches with the 5, the 7 only matches with the 5, and the 8 only matches with the 1. Each x value has only one partner. Okay, the next example is not a function. Okay, why is it not a function? Because each x value does not match with one unique y value. So in the case of this one right here, the x value goes with 4, but then when I get here, the same x value also matches with 5. So because that element of domain matches with the 4 and the 5 in the range, that is not a function. And some of you learned in Algebra 1, if the x's repeat, it's not a function. So in this case, because the ones are repeating, this is not a function. For the first one in the table, because the x's do not repeat, it is a function, something like that. Okay, to test for a function, whether something is a function algebraically, okay, there's kind of a long way to do it and a short way to do it. So I'm going to show you the long way to do it, and then I'll also show you the short way to do it, and then we can determine, you can decide which way you'd rather use, although in some cases you might use one or the other. Okay, I'm going to solve for y. Okay, so I'm going to move the x to the other side, so I'm going to get 5 plus x. Okay, and then to solve for y, I'm going to square root both sides. So I get y equals plus or minus the square root of 5 plus x. Okay, and this is the same function, the same relation, I just rearranged it. Okay, and I did have the plus or minus because it was y squared, and therefore I got 2 radicals as my solution. Okay, what I want to see is for each x value, is there one unique y value? For this particular one, let's say I plugged in an x value of 4. 4 plus 5 is 9. The square root of 9 is 3. So I would get y equals plus or minus 3. Well, that means if I plug in 4, I get 4 comma 3 and 4 comma negative 3, which means it cannot be a function because the same x value maps to more than one y. I could have also noticed that because I can see that there's a plus or minus in the front here. And that's telling me that it's going to not be a function. Okay, I'm going to do one more the long way, and then I'll show you what the shortcut is. Okay, for the next one, it's x squared plus y equals 10. I'm just going to rearrange it real quick. So it's solved for y. Y equals 10 minus x squared. Okay, and then I just need to kind of ponder that. If I plugged in x is 1, I would get y is 9. That's only one value. If I plug in negative 1, I can only get one y value out. But really, since there's no plus or minus coming out in front of the x, this is going to be a function. Okay, now how could I tell without actually having to solve? Okay, I'm going to go back to the first example. I look at the y value here. At the leading y term, if I solve a y squared equation, it's going to produce two different y values. Since this produces two different y values, I can tell without doing any work that this is not going to be a function. And you would not have to show work from it for that problem. You can just look at it and tell from there. Okay, if I look at this one, I just look at the y term, the leading y term. Okay, this is y equals. If y equals something, it's only equaling one y value. Because it's only going to produce one y value for each x, this is a function. Okay, I'm going to try to do the next ones, thinking about whether this is going to give me one y value solution or two. Okay, so if I don't want to do any work for this, I'm going to look at the y term. Okay, now think about it. If I solved an absolute value of y equation, say it was the absolute value of y equals 2, I'm going to get y equals plus or minus 2. So I'm going to get two different y values because that is going to give me two y values, different y values. Without doing any work, I can tell that this is not going to be a function. Okay, and then for the last one here, I'm only going to look at the y term. So in this case, y to the third. And then I want to think about if I had y to the third equals something and I solved it, would I get one y value or would I get two y values? Okay, y to the third equals 8, I only get y equals 2. Y to the third equals -8, I only get y equals -2. Y to the third equation only produces one y value. So this is going to be a function because it produces one unique y value for each x value I input. Okay, for the next example, we're going to practice stating the domain of a function. Some of you did this. You guys already did this on your summer assignment. You did this in Algebra 2, and you did it a bit in Algebra 1. Remember, x is the values of x that are, domain are the values of x that are valid for the function. Okay, so for the first one, it lists out f, the function f, as a set of ordered pairs. For this, in this case, the domain is going to be the x values. So the only possible x values on this are -1 and 2, because that's the x value and the x value. You can list it like this. They often use those curly brackets when you're making a list of numbers. So this is saying the following numbers are eligible, -1 and 2, and that would be my domain. Okay, you're probably more familiar with when there's a restriction on your domain. Okay, so for part B, for my domain, okay, the one thing most of you guys remember is you cannot have a 0 in your denominator because you cannot divide by 0. So whatever's in your denominator cannot equal to 0 because we can't divide by 0. So if I rearrange this, let me add 4 to the other side, I really determine that x cannot equal 4. Okay, so one way to write that would be to all reals, but x is not equal to 4. So any real number can be plugged in here except for 4. Okay, and if you wrote this in interval notation, that would be equally correct. I'll review interval notation at another time. Okay, the next one is also a rational function. Okay, when it's a rational function, again, what do we care? We care that the denominator cannot equal to 0. Okay, if you can do it in your head, I'm fine with it. I think I'm going to show a step real quick. Let's see, x squared minus 3x factors to x times x minus 3. And that can't equal to 0, which means x can't equal to 0, x can't equal to 3. So my domain would be all the real numbers except x is 0 and x is 3. And you can write it in different ways as long as you're expressing that it's everything except 0 and 3 in it. Interval notation's fine, words are fine. Okay, the next type of function that has a domain restriction that you probably remember are radical functions. And that's because we cannot square root negatives in the real domain, but we can square root 0. So whatever the radicand is in here, the radicand must be greater or equal to 0. Okay, so in this case, my domain is going to be, well, x just has to be greater or equal to 0, and then that's fine. You could also say non-negative numbers, all reals that are greater or equal to 0, something like that. Okay, now this one, let's see, we have a radical on the numerator and we have a rational function, so there are two domain restrictions to consider. What should I do? I'm going to do the denominator first because that's just easy. Okay, since it's a rational function, whatever's in the denominator cannot equal to 0. So I already know that one thing I know is that x can't equal to 0, or x can't equal to 7, because if I add the 7 over, x can't equal to 7. Okay, the second restriction is that there is a radical. So whatever's in the radical has to be greater or equal to 0 because I can't square root negatives in the land of real numbers. Okay, if that has to be greater or equal to 0, then x is greater or equal to -2. Okay, so what's my domain? My domain is all real numbers greater or equal to -2, except x can't equal 7. Okay, and this can be expressed in interval notation or in words, which is equally correct, and I will show you interval notation on another day. Okay, a couple more domain restrictions, and then we'll do some function notation. Okay, let's see. See, this is a rational function, so I do know the denominator can't equal 0. So it's true that this can't equal to 0. But what else is true? Oh, it's also true that because it's a radical, it has to be greater or equal to 0. Okay, so x minus 1 can't equal to 0, but it has to be greater or equal to 0. Okay, well, but it can't equal to 0. So it must be that x minus 1 is greater than 0 because it can't equal to 0. So if I find the domain for this, it would be all reals greater than 1. And if you're not sure, pick some numbers greater than 1 and make sure they're valid, or pick something less than 1 and show that it's not valid. Okay, the last domain is a cubic function. Now, the cubic function doesn't really have a restriction. If I do the cube root of 8, I get 2. If I do the cube root of -8, I get -2. If I do the cube root of 0, I get 0. So all of these values are legitimate, so I can actually plug any number into a cubic function, and that's true of any odd indexed radical functions. If that was a 5th root, a 7th root, a 9th root, it would still be all reals, whereas if it was a square root, a 4th root, etc., I would have to make sure it was greater or equal to 0 for the radicand. Okay, now we're going to review function notation. So for example 4, it says if f of x equals x squared plus 3 and g of x equals 2x plus 18. For the first one, what is g of -4? And if you recall, this just means this is your x value. So in the g function, plug -4 in where you see x. So 2 times -4 plus 18, and then evaluate. So -8 plus 18 is 10. So g of -4 is equal to 10. Okay, that happens to also represent the ordered pair -4, 10. Okay, I'm going to do the same thing on the next one. This is f of n plus 1, and I say f of n plus 1. Okay, so I'm going to take the n plus 1 and plug it into the f function where the x is. Okay, so n plus 1 squared plus 3. I can't exactly evaluate it because there's a variable, but I can simplify it, and I am going to simplify it the best I can. If you recall, n plus 1 squared is n plus 1 times n plus 1, which is n squared plus 1n plus 1n plus 1, or n squared plus 2n plus 1 plus 3. So I get n squared plus 2n plus 4 is my answer. My answer is an expression because I plugged in an expression. And as a reminder, this was because n plus 1 squared is n plus 1 times n plus 1. And then you multiplied it all out. Okay, for C, it says find x if g of x equals to 0. So what is the g of x? G of x is 2x plus 18. So let me see, if I 2x plus 18, let's set it equal to 0, and they want me to find x. Okay, let me minus the 18 over, divide by 2, x is -9. They wanted me to find x, I found x. Okay, and the last one with function notation says find x, so f of x equals g of x. So f of x is x squared plus 3. I want to set it equal to g of x. G of x is 2x plus 18. And they want me to find the x values for which this works. Since I see there's a squared, I'm going to get 2 answers. Let's see, I'm going to leave the squared alone. I'm going to minus the 2x over to this side. I'm going to minus the 18 to the 3, so that's minus 15. Let's see. I'm going to try to factor this. This will factor. X, 5 times 3, -5 plus 3. So x is 5 and x is -3. And it said find x when f of x equals g of x. So my x's are 5 and -3. Okay, the last thing in the function section we're going to go over today are piecewise defined functions. And this is one thing I don't know if you have seen before. Okay, piecewise defined functions just have more than one piece to the function. So part of the graph looks like one thing, part might look like another. It could have 3 parts, 4 parts, however many parts you want to have. Okay, but they give you a rule for it. So in this case, f of x equals 2x squared when x is greater or equal to 1. Okay, f of x equals x minus 5 when x is less than or equal to 1. Okay, so let's try f of 3. Now I have to look. If I plug in 3, is 3 greater than 1? Yeah, 3 is greater than 1, so I'm going to use the first function. So since x is greater than 1, I'm going to plug it in here. So 2 times 3 squared, do the exponent first. Okay, I get 18 for that. Okay, now I'm going to plug in, it says plug in -2. Okay, now is -2 greater than 1? No. Is -2 less than or equal to 1? Yes. Since -2 is less than or equal to 1, I'm going to use the second expression for the function. So that's x minus 5. Okay, so what is x? -2 minus 5. So I'm going to get -7. Okay, and then one more. It says f of 1. Is x greater than 1? Is 1 greater than 1? No. Is 1 less than or equal to 1? Yeah, it's less than or equal to 1. So I'm going to use the second function rule again.